everyone, welcome back to my math teaching online today. In this video today, I'm so happy and exciting to show you the lesson of volumes of solid revolution. The reason I'm happy to show you this question because this is a fascinating topic. Back in 25 years ago when I was learning in the university. Until now, I still love this topic. And the reason I love it because I love drawing as well. I love something like artistic. And on the board, you can see that I use my artistic skill to draw the shape of the volume of solid revolution. So anyway, let me talk about the question today we are doing. Before we get into the question, I want to remind you a little bit about what we did in the previous video. So in the previous video, you already learned with me how to find the volume of solid revolution of the object under the region under the curve, one function. And the method we use is the this method. We have two ways of doing it. One is this method and another one is shell method. But we just complete this method for the previous question. And today we will continue to use this method as well for this question. Now also adding into this technique we're going to use is the washer method. What is the difference between this method and the washer technique? It's not much different. It's just slightly different. Today we will generate the region between the two curves, and therefore we need to use the washer method in this topic. Anyway, let me review for you what is this method. So imagine that this is the volume we want to find out, right? The perfume bottle. And for this method, we call this because we're going to slide this volume into a very small cross-sectional area. And our cross-sectional area is a circle or like a dish shape. And therefore we call it dish method. So the way we slide them into so many small slides, we call it derivative. And then we use iteration, which is we undo the process, which is antiderivative, which is we're going to iterate the region and revolving along the axis. And to connect these so small slices together and to form the volume. So basically that is the idea. Now I'm going to get right into the question. So sorry, I have to close some of the advertisements that pop up. But anyway, so let's read the question with me together. Find the volume of an object that is generated under the region between y equals sine x and y equals cos x from 0 to pi over 4. Is rotated about the x-axis. This needs to be done using washer method, known as this with the hole. So I'm going to explain to you what do we mean this with the hole, right? So if you have, let's say you have a big circle like this, right? And we call this a disc. Then you also have a small circle inside. And remember back in the high school in grade 7 or grade 8, we already learned this. If we want to find the shaded area surrounding, this look like a donut, right? Surrounding like this, we going to use the whole area, right, the whole surface area of the big circle, subtract the blank here, which is the area of the small circle, so that we can get the area between them, right? And we say we're going to use a big, so area big minus area small to get the shaded area. So that's the idea we learn in 2 dimensions. Today we learn in 3 dimensions. But this is similar idea. The only difference is we deal with volume instead of the area. The area is 2 dimensions and the volume is 3 dimensions. So that's the only difference. And because we have a home here, so we say that the washer method is talking about known as this with the home. So you see, this is this with the home. So here you go. I'm explaining to you the sentence. Okay, so the title of it, right? So now I'm going to talk about our geographic shape, geometric shape. So the question said, find the volume of an object that is generated under the region between y equals sine x and y equals cos x. So if you look at on my right hand side on the board, this is the y-axis and this is the x-axis. And I draw the 2 curves. The curve here is the cos x. And everybody learned trigonometry. You know that the curve, the maximum cos x on the y-axis is at 1. So this number is at 1. And the starting of at the origin for the sine curve, which is the second curve here, the sine curve, and the sine curve start at 0. The cos x start at 1 and the sine x start at 0. That is how we distinguish between the 2 curves. Now, they are the same shape, the same wavy shape. It means this curve continue like a wave, but for the purpose of doing our question, I only draw a portion of the curve. We don't have to draw the whole thing, right? So I just draw the y, the cos x from here to here, and the sine x from here to here. And from here to here is 0 and pi. So half of it is pi over 2, and then here is pi over 4. The intersection between the 2 curves, make the observation with me, right? The intersection between the curve here indicate they meet at the intersect at the x coordinate at pi over 4. Underneath here, I mark it pi over 4. So that's the intersection of the 2 curves. The second thing I want you to notice is which curve is above and which curve is below. So let's make an observation. Now, the curve, the cos x here on the top, you can see that, right? And below this curve is the region, the shaded region I mark here, right? The shaded, the piece, small piece here I mark here. That is the shaded region. Below this curve is a curve of sine x. So the sine x is below and the curve x is, the cos x is above. And because the cos x is above, so when we generate revolving this shaded region, the region underneath this cos x, we produce the big dotted shape here, which is, I transfer to here. This is the outer shape. So the outer volume. So the outer volume is a big shape here with the blank color, right? The empty, the blank color, the white color. What is the blue color here? The blue color here is the volume of the object result in the generating, revolving the region below the function sine x. So when you generate the region below the function psi x, it results in this volume, the blue one, inside. So the psi x produces the volume inside, the small volume inner, and the cos x revolving a big volume outer. So in order to find the region, the volume between these two shapes, which is the region, the shaded, the small piece shaded region here, we have to use a big volume outer, subtract the volume inner. So I'm going to write out, okay? So V region, which is the volume of this region, right? The shaded region I mark here, right? V region will be equal V outer minus V inner. V stands for volume. So volume outside minus volume inside. And when we do that, we will get the result of the volume between these two shapes. Just like we're talking about the area, the home, the donut shape. We use the whole full circle, right? Minus small circle. So we can get the shaded area around of the donut shape. Instead of donut, this is the volume, not the area. But the idea is very similar. You can see that, right? You can relate it. So we're going to use the big volume here. And the big volume is represented by we generating the region under the cos x. And the volume inner represented by generating on the region below the psi x. So now, after we do this, what we're going to do? We're going to find that volume, right? Now, for this question, because we already learned how to use the Riemann sum and we reconnected with the concept for that. So we know what we're talking about, the sliding the volume in the small disk slice, and that we call a derivative. And then antiderivative means we integrate, right, the region, and we get that. So after that, we develop the formula. So now we just use the formula to make life is a lot easier. And that's why math for. Math is always try to do in a short way after we understand the complex picture. Just like the multiplication, instead of adding, we do multiply to make it easy. So now, instead of doing Riemann sum, we make it easy by using integration. So how do we do this? So we're going to use a formula, right? So we're going to say, we're going to integrate from A to B. And remember this method, it means we find the area of the cross-sectional, right? Cross-sectional of a disk, and the area equal pi r squared. Unfortunately, the r here, we're talking about the whole function is no longer to be a fixed number like r, because the radius here, you can see that for the cos x here, the radius, right? We're talking about the disk here, right? So this from here to here is the big radius outside, right? But then it gets smaller and smaller because the function, right? As the function changing, then our radius always change from big to small, smaller. And therefore, this radius is not a fixed radius. And therefore, we have to use the function our radius is the function of the cos x function. It's no longer to be just number 2, number 3, number 4, number 5. because this radius, it keeps changing. It's a variable, right? And that variable is a function, right? Our radius shape along with the function, right? So this r here, we substitute by the function f of x and square it. Now pi is just pi, the formula, right? To find the area. And time with delta x. And what is delta x? Delta x actually the length of each cross-sectional area. Let's say you have the cross-sectional area look like this, right? So this thickness from here to here is delta x. The thickness of your, thickness of your cross-sectional area. And this is delta x. Now when we're adding them along, we get the whole length, or we call the height if we stand it up, right? So the whole length here is from the region from A to B, the interval from A to B. And each thickness here, we call it delta x for one cross-sectional, right? So that's the idea. Back in the videos, previous video, you have seen that already. I just recall it to you, right? So this formula is, we say pi r squared times with delta x. That gives us the volume. Now volume equals, we substitute r by the function because we know our radius changing according to the function. And we just follow the formula. If it is square, we square. If it is cube, we cube. That's it. And then time with delta x. So that is the formula. So I'm going to put this formula in here, which is pi r squared, but our r is f of x. And this is square. Now, if we do the Riemann sum, we have to multiply with delta x for each sectional area. But because we already taken count in the generating from A to B, which is the interval from A to B for the length of the volume, right? Talking about that, right? Imagine this volume of the cylinder, right? So from here to here is the interval from A to B, which is taken in here. So we don't need to time with delta x if we use the formula of the iteration. So that's the idea. So now let's use the iteration formula and do this question, right? So we have a V outer and V inner. So we're going to do both of them, and one from 0 to pi over 4. So I substitute A by 0, which is here, right? And B is pi over 4, actually pi over 4, right? This one, pi over 4. So pi over 4. Now the volume outer underneath the cos function. So I'm going to put here in cos x dx minus the same like from 0 to pi over 4, and volume of the inner is sine of x dx. However, remember, what do we missing? We're missing the pi, right? We should have a pi here, and we should have a pi here according to the formula. Also, the function cos x here is supposed to be cos square x, and sine here is supposed to be sine square x, right? According to this formula. Now, I'm going to put them together, right? Equal 0 pi over 4 pi. I'm going to factor out the pi outside because they both have a pi, right? Common factor. And inside, I'm going to say cos square x minus sine square x and dx. So I put two of them separate in one of them. Okay. So now this is the answer, but we haven't finished yet. we have to continue and do our iteration, right? Finish our task. So I'm going to do it here, okay? So the iteration of this, cos square x minus sine square x. Before I do that, I'm going to simplify this function first. So I'm going to say 0 to pi over 4. Now, if you learn the trigonometry identity in the Math 12, everybody should know that based on the trigonometry identity, cos square x minus sine square x equals cos 2x. If we have cos square x adding with sine square x, then it equals 1, right? That is the trigonometry identity we have learned in Math 12. So I'm going to put in here, this is the result of cos 2x. That is the trigonometric identity. So pi outside and beside that will be cos 2x dx. So now we're going to do the integration. So pi is still pi. Cos 2x will become antiderivative of cos 2x is sine 2x. So sine 2x. However, we have to time with 1 over 2. 1 divided by 2 because our angle is 2x. So this is the antiderivative of the chain rule, right? Okay. So now we integrate from 0 to pi over 4. So the answer for this will be pi, just pi. Sine of 2x will be sine of 2 times with the x angle, we substitute x by pi over 4 minus pi sine of 2 times with 0. Now this will cancel out and we have the result in pi of sine of pi over 2 minus. If you learn about trigonometry, you know the coordinate here is 1 and 0. So if at the angle 0 degree or 0 radian like this, right, the sine of that angle is 0. So we substitute the whole thing here equals 0. That's the value, ratio value of sine angle. Pi times with 0 is just 0. So the whole thing equals 0. So we don't have to worry about this. It's just minus 0. Equal pi sine of pi over 2. So this is pi over 2 angle on top, and the coordinate of it is 0 and 1. So sine of pi over 2, this is sine, this is cos, right? So sine of pi over 2 is 1. So this is pi this is pi. Okay, I'm missing the 1/2 here, right? So I should, sorry about that. I should have a 1/2 in front as well, okay? So will be equal pi times 1/2 here, right? Now sine of pi over 2 equal 1. So let me rewrite it more carefully, otherwise you won't see my handwriting. Let's do this again. I'm going to have to bring out in front so that I don't forget, right? So this is 1/2 times with pi, and 1/2 times with pi, let's put just pi over 2, okay? So equal pi over 2 times with sine of 2x, which is sine of 2 times with pi over 4. And cancel the 2 with the 4, we have this root is sine of pi over 2. So we have pi over 2 times with sine pi over 2 side of pi over 2 is this coordinate, which is 1. So pi over 2 times 1 minus 0. So the answer for this is pi over 2. Cubic unit, right? Volume is cubic unit. Now, if you notice in my previous video, and I did make a note under that, like by habit, I keep saying like square unit, which is my silly mistake. It should be like cubic unit, right? Because we're talking about the volume. But anyway, so now it's a pi over 2 cubic units for this volume. So let me summarize what we did here. Now, the calculation is not too bad. The computation using the technique of iteration, it's very easy to find the area or the volume or whatever. However, the geometry, shape, and the thinking and the concept is a big deal in this topic, right? How do we can visualize what we are doing? What is the shape when we generate around, revolving around the axis? What kind of shape we generate under the function and using the blend region doing that, right? Or in the future, we will learn the lesson we generate revolving about the y-axis. So the calculation is not a big deal in this topic. If we all learn about iteration, we should know that. But the concept, thinking, the visualization, how we can visualize the shape is a big deal in this topic. And how we can, if we do geometry, but we don't visualize it, we don't see the shape in three-dimensional thinking, then we might miss something, right? And we might make the error. So the conceptual thinking is I believe that it's a little bit complex, right, in calculus. So let's focus on that, okay? Let me summarize that for you. So we have a two curve. One is a cosine and one is a sine x. The question asks us to find the volume of the shaded region, the intersection between the two curves, right? We're going to find the volume of the small piece here, right? Formed by the two curves, cosine and sine x, to form this piece, to form this area. So the question asks us to generate the volume under this and find the volume of this piece shaded region underneath the two curves, cosine and sine x. So how we do that? First, we have to realize the cosine is above curve and the sine x is a below curve. And they intersect at the x-coordinate of pi over 4. So we shade the region and we know the interval we generate from 0 between 0 and pi over 4. So then we visualize it. We say if we use a cosine here and we generate revolving this region below the cosine, we will form the big shape here like a bucket, and we call this is the outer volume, right? Under the above curve of cosine. Then we visualize that if we generate the region under the sine x here, which is this region, when we generate, we produce the solid volume of the inner shape here, which is the blue shape. I draw it here. Our task is to find the volume between these two shapes, not the whole volume of the big one or the small volume, but the volume between them. Because if you realize that the volume between them is generated underneath the shade this shape, which is just a small piece here. And to find that, we have to use a big volume of the whole thing under the cos-x region and subtract the volume of the small region when we generate it, which is the blue color here. So I mark here V region, is the volume of that region, equal outer volume minus inner volume. And we're going to use this method, which is to find the volume. We know the formula is V equal pi r squared, which is the area of the base, times with the height. And the height here is the result of delta x. So fortunately for us, the r here is the radius of the dish, which is, if I'm talking about the dish here, right? The radius from here to here is the r, but our r is not a fixed number. Our r is changing according to the cos function and the sine function. So the r here is keep changing. It not stay the same as a fixed number. And therefore, we substitute our radius by the function because the radius was shaped by the function, according to the function. So we substitute the formula here, r, by the function, f of x. And we just follow the formula, we square it, and the delta x here, because we use a technique of integration, not the Riemann sum, right? So therefore, we take care by generating from A to B already. We follow the formula up to find the volume of the disk, which is pi r squared. Our r is the function f of x squared, dx. Then we substitute the function in, and we use the trigonometric identity. We know that cos square x minus sine square x equal cos 2x. Then we simplify the function and we get this. And then we just do the integration like we always did before. So that's enough for my video today. That's it. That's for the video today. And I hope you enjoy my teaching, my drawing, and my explanation in details, right? The next topic we learn will be continue with this topic. We still use this method, but we will generate revolving our solid object, revolving around the y-axis, not the x-axis like this anymore, but we will do by the y-axis. Now the idea is very much similar, except that dx will become dy, and the function fx will become f of y instead of x. That's the idea. So stay tuned for our next video. If you like my video, please hit subscribe and hit like button. Now I know that I will never make a perfect video, right? I try my best and try to make it more in a deep thinking and, like details and explain in details for you. And I try my best. And sometimes I might make a silly mistake, like the units should be the cubic units, but I forget and I put square unit, but that's a small mistake. So, but anyway, you know what I mean. And I hope you enjoy my video. And thank you for watching. So bye for now and stay tuned for the next video. We will talking about how we generate the region revolving around the y-axis. But anyway, before you go, I'm going to, sorry, this is bothering me because you might not see it, but I seen it like the pop-up of the advertisement, and I'm not so good at techniques. I don't know how to prevent that. But anyway, before we end the video, I would like to remind you a little bit. You can learn, you can buy my courses online, right? And I make the, at least I think that is 40% off already for my courses online. And if you get into my website, you will know the link, right? However, I also have another website I introduced to you, and you don't have to learn the full course because sometimes you have to learn from the school as well, and that will make you tired, like too many courses, right? So you can get into my website, because if you want to understand the calculus, if you're taking the calculus in university, you watch my video, something like this, you connect it with your lesson, you will understand better and you will pass your exam in university. You have that privilege. I didn't have it back and when I was learning, to be honest with you, right? Also, if you want to learn weekly lesson, because I just post weekly, right? Sometimes I post like 2-3 more video, or sometimes 4 video at a time, sometimes 2 video, but I call that the weekly lesson video. And weekly lesson video, not in my teachable.com, but underneath the link, mymathteaching.ca. So http:// mymathteaching.ca. Very easy to remember, just mymathteaching.ca. Stand for Canada, right? I am living in Canada. So mymathteaching.ca, you subscribe to my channel, and I call it my online teaching channel. And if you subscribe or donate a small amount, $7, $5 or something, yes, around that, right? You can get into the weekly lesson, and you can donate monthly or you can donate one time. And in the supply, now I have to get something back from my labor and my energy so that I can produce more video and continue with our channel. I still have to support my living, right? So that I can continue the great work I love, and I hope that you love as well. For our free online education. So I provide tutoring one-on-one. Now you are facing with me like this. It's the same like I'm teaching you one-on-one private tutoring, but it's a lot cheaper by subscribing to my channel online, mymathteaching.ca, right? And subscribing that, you can learn the weekly lesson. I am going to make more and more of this video. It's not just the calculus. I'm going to will give you the whole course in finance course in the first year university. Well, I'm going to make like another course like pre-calculus 12, geometry, so on, so on. But I need to eat to have my energy. I need food, right? To provide my energy to provide you on the online course. So please support my math teaching online by subscribing to my channel, going to mymathteaching.ca to enjoy your watching video and learn online learning. So thank you for watching, and bye for now. And stay tuned for our next video. I still don't want to go. One more thing I just want to remind you, I promise. If you get into my supply channel, you can have the course connected and related, just like you buy a home course. But now you learn a piece of it, right? Along each week when you go along with it. If you watch the YouTube like there's nothing wrong with that. I still need you to watch my YouTube videos. However, they're not connecting because one jumping to another video and from another professor, you might enjoy better. But in my experience, if you stick with one teacher and you follow their method, your learning is more understandable and more consistent, and but it's up to you. Now, if you like the way I'm explaining and you like this, you better like getting into the course online or subscribing to my channel, wordpress.com, mymathteaching.ca, because that will give you the connection one after another lesson rather than jumping one and another one and on over and you don't remember, right? So that's it. That's what I remind you. So thank you for watching and I hope you enjoy. Bye for now and see you in the next video.